Good evening, bonsoir, everyone, and thanks for coming to Season 2, Episode number 3. This is a new season this year, and it speaks about a lot of custom projects from all over Canada. And we are very proud of our community here in Toronto and all over Canada because we have multiple partners working with us, and they are all contributing to this showcase from NeuroTechX, which is about applications, hardware, and software. Good evening, John. How are you doing tonight?
Good evening, Chris. I'm very good, thanks. Good to have you back with us.
Yeah,
I
thanks.
think Brian did a great job in your place last time. How was Berlin? Treat you well?
Yeah, Berlin was fantastic. A lot of neuroscience and neurotechnology going on there too, right?
Mm-hmm.
And I can report that on a new episode. And but I'm really excited to have Mark David Hosale tonight with us. He's an artist and a composer, and by the way, he's also associate professor and chair of computational arts in the School of the Arts, Media, Performance, and Design at York University in Toronto. It's quite a mouthful to say, but I want to give credit to our guest tonight. And
I think it's a mouthful
John,
to think as well. He has an expansive profile in a really great way.
Yeah, I'm really excited about this synergy between neurotechnology and art. It will speak a lot about arts, performing arts, and I don't want to give any spoiler tonight, but how cool is that to have an artist tonight at NeuroTechX Showcase?
You know, it's great, and I think it's also representative, right? I mean, sure, a lot of the stuff that we do and people we talk to is often somewhat to do with brain specific things, cognitive specific things, health specific things, but I definitely know lots of people and have seen lots of activity in the creativity, digital arts, performing arts space and that kind of neurotechnology intersection. So it's good to have someone on, and it's like it's not just a one-off. Like this kind of thing does happen quite a lot.
Yes. And then there is a lot of technology behind arts as well, performing arts. Although I think in this case, there is a lot of telemetries from the body that Mark David will speak about tonight. But, so in the case of this performing arts, John, there is a lot to say about emotions. Like artists are in contact with their emotions, they say. So to be a good actor or a good performer, you have to be in touch with your emotions. So wouldn't there be, would there be a good technology that allows us to tap into our own emotion, the interoceptive sense as an artist? And then would that be great if there would be some technology that brings it out as an objective measure? So measuring emotions is quite controversial, I think, because emotions are subjective, right?
Well, I think yes and no, right? So historically, and maybe Mark David will touch on this, but I guess we're kind of all familiar with things like galvanic skin response, like lie detectors, things that are looking for peripheral nervous system indicators of arousal, right? And but there's actually a lot of action in that space in contemporary neuroscience in terms of kind of emotions, but also the relationship between like the body and the brain, right? This like gut brain axis, vagus nerve relationships, and how that kind of relates to things like interoception, and how that in turn has some kind of role in your cognitive makeup and like the conscious mind. There's definitely people kind of making connections in that space, and it's not like a new thing. The interesting thing is, I think, how stitching things together, right? As always, that's always been the theme of all the things we've talked about, right? It's like a bit of science here, a bit of technology here, a bit of application here, and really finding a great nexus of those things.
Yeah, it's a great way of putting that. So the nexus between technology, neuroscience, art, emotions, and then also what you mentioned, that it is possible to objectively measure a proxy of emotions. And you have facial expressions, galvanic skin response, like you said, muscular signal, heartbeat, the skin
Yeah,
temperature.
vascular. Yeah.
So a lot to do for engineers there too. But before going into that, I'd like to have a little bit of an excursus about the NeuroTechX, explain a bit about NeuroTechX if you like, and then give a couple of announcements of events in Toronto if it's fine with you. Let's do it. So let's see if I can put on the side. I'm sharing my screen. So here you go. This is neurotechx.com. This is the community internet site, landing page. You can also see the numbers, how many communities and what we promote, which is community education and networking. Of course, there is an aspect of networking that has to do with professional development, and then we get to that. However, if you want to subscribe to the Slack, you can be online with all the greatest and latest. So you have to click on this button here, and there are other features, including the career opportunities section here, that I strongly advise if you want to look for a job. So having said that, there are a couple of announcements regarding events in Toronto this week, starting from tomorrow. There are a couple of events from my own company I work at, which is ANT Neuro. So we promote two events on Thursday and Friday. One is in the evening of Thursday, and the other is in Friday morning. And it's in collaboration with Western Hospital, the group of Dr. Robert Chan. So we thank them for hosting us. And it's free. Participation is free. So please look at the site ANT Neuro and then click on the link if you want to join and subscribe. Having said that, I think we can go to our guest. Let's invite Mark David on screen.
So just a reminder to everyone, we want to have questions and comments. We've got some good comments and general chatter going on right now, but we have the questions box. So drop your questions in there for Mark David, and we'll try and relay them to him as the conversation goes.
We'll follow up. Hi, Mark David.
Hello.
How are you tonight?
Good. Greetings from my secret basement lab.
Yeah, it's nice to see a lot of technology around you.
Well, I've been sequestered to my basement during COVID since we're only recently being allowed to go back to campus. So, so this has turned into my new lab.
Sounds like fun.
Yeah.
So this is York University?
No, this is my basement at my house.
All right.
Yeah. Wherever I go, I tend to make the same mess, though, as it turns out.
It's probably to do with the artistic side of you.
Yeah, well, it's a bit of my life's a little bit left brain, right brain, so I'm doing coding and a lot of electronics and working with like 3D fabrication. And so there's a lot of math also involved in my life. And then, but then on the other side, I'm also working with creativity and expressing and, and that's, so it's kind of, I can kind of balance the two as much as possible.
Yeah, we're looking forward
to
see.
What brought you to that point, Mark David? Like, I don't know if you have this as like an explicit part of your show that you're going to get to, but tell us about, what made the man.
Well, it's a long journey. I guess the way I would say is that I started out in music. I mean, I was always interested in working across the arts. So even at a young age, I was playing with the arts, but I was always interested in electronic music, especially. And then in university, I got, let's say, reasonably knowledgeable at working with computers and electronic music, and that's what led me into coding. And my master's is in music composition and theory. Then for my PhD, I was kind of, we have another podcast about why I got fed up with studying music, but I got fed up with studying music, and kind of in that journey, I ended up landing in a program called Media Arts and Technology, which is at UC Santa Barbara, and I ended up being the second PhD to graduate from that program. So I was also kind of shaping the PhD as part of my PhD, and that's a program that combines visual art, music, electrical engineering, and computer science in the same program.
Wow.
And then when I about the time I was graduating, I was started collaborating with an architect and in Los Angeles, and I ended up moonlighting at Southern California Institute of Architecture and taught a course there. And then I moved to Netherlands and ended up becoming a professor in architecture, and but not teaching architecture, teaching interactive like design and experience in architecture. And we were doing like large scale architectural installations, things like that. And then after that, I ended up at York and helping really build from the ground up a program very much like where I did my PhD. So it's like we're a program that's between computer science and art, and so we're working, across those fields. So and I do a lot of work with I've done a lot of work with art science. I get, in a way, the architecture is kind of like art science, although that's a design field. But I also collaborate with an astrophysicist who works in a lab called IceCube, which is an observatory in Antarctica that's a cubic kilometer embedded in the ice. And so I've done projects around that. And then
I think we shared the link before.
Yeah, I think it's. I'd have to find the link, but
yeah, IceCube Antarctica probably wouldn't quite find it.
Well, you could find you can find all those projects there, and
right.
And then
there, I can share the link on text.
Yeah, and then the artworks here. I think they were shared before, but at any rate, so the yeah, and then I don't know. It's a long story. How in my brain, there's a link between all these just disparate things, but that's kind of the journey. And I don't know. There's probably some gaps I didn't fill in, but that's a good gist.
I'd really love to hear more about the program, and I think probably like a fuller version of the question will come when you've given us a little bit more, but I just want to jump in on that anyway. I mean, are you kind of looking for people who tread the line and are kind of in both worlds, so to speak, or are you kind of looking for people and kind of forming people who are, going to be a engineer, but building them out in the kind of artistic domain, and then people who are going to be working in the arts and building them out in the engineering domain, and kind of just giving people a broader profile? Or you're kind of really trying to have people who are fully spanning both areas? Like, how do you think about that?
Well, kind of yes to all the above. I mean, I think, and I mean, it kind of worked that way in my PhD program as well. But I think what happens is you do get a lot of students who kind of, it's like a spectrum, and they fall on the spectrum. So anywhere from artist who wants to, be in the gallery scene or whatever, and then to engineer who wants to work with media. And like, so for example, in the PhD program I was in, they, we had people go work for Dolby and designing like um, encoding and decoding schemes for spatial audio, or and then you'd have artists who become internationally famous, so that that's all there, and those possibilities are there. And the other thing about the program, I mean, from that point of view, is that it also allows a lot of fluidity. So I mean, I think today there's a lot of people are kind of working multiple jobs in a way, but they're also they're the boss, I guess, of their job, and the kind of gig economy. So we could also imagine a student who's you know um, working on an app or a website or something Monday through Wednesday, and then on Thursday they're installing their latest artwork, and then and so on. And so there's this kind of ability to kind of move between roles or change careers. And we also try and teach that way. So we don't teach necessarily married to specific tools, but we try and teach paradigms, like visual programming, object-oriented programming, scripting, UX, all these different elements, and do like a full stack education, so that people can kind of adapt to what's coming. Because what's funny is you think about how much has changed in 5 years, in the kinds of tools people use and what's popular, things like that. And then you think, it takes 4 years to get a bachelor's. So that by the time when they start and by the time they graduate, the paradigm's already going to be shifting. And that, it seems to be accelerating. So anyway, but then from the point of view of an artist, the way I look at it is coding and engineering. That's my paintbrush. So, and I guess one way you could think about it is like art, like anything's a way of knowing. And when we encounter problems in art, so if you're a painter, if you're going to approach a problem in art as a painter, you're going to solve it with painting, whereas I solve my art problems with technology.
Beautiful. And you wanted to also use your paintbrush tonight to, show us what you have been doing in the past. I know that recently you were in Portugal, right?
Yeah.
What did you do in Portugal?
I was very honored to be invited to this workshop called Music Tech Fest, and it's a regular event, and to be honest, I didn't know much about it before like a few months ago, but in this particular instance, everyone who was there had to be invited, and so it was in a city called Aveiro. My Portuguese is kind of stinky, but it's a city about 80,000 people, south of Porto, and and they're really pushing to become what they call a STEAM city. So if you're familiar with this idea of science, technology, engineering, mathematics, so STEAM is this concept of science, technology, engineering, art, and mathematics. And and so they hosted this event there, and we had about 50 people from around the world come together in this intensive week to think about the ocean. And so the event was called Just Ocean, and what's happening to the ocean. So things like sea level rise, pollution, even like noise pollution, which is actually a huge problem in the ocean, and global warming in general, microplastics, and and to create works thinking about that. And so it starts off with presentations and talks, and then brainstorming, and then you get into these like a couple of intense days where you produce an artwork in 2 days with a huge team of people. So it's very exciting. And so, yeah, we brought our wares there, and we worked on a very fast fast but exciting performance piece in engaging biotechnology. Yeah.
So bringing together all this technology and the thematic representation, art presentation, I guess, was that difficult? Is that something that you're working on for a long time?
What do you mean, like bringing together art and this kind of technology? Is that what you're asking, or?
Oh, I was asking if bringing the technology to the event and setting it up and building up the system, which I guess you will talk about, was that something that you have been doing for many years in the past as part of the educational stream that you're teaching at York University, or is a personal project? How long does it take to have an installation like that? And then how many hours does it take, many work hours?
Well, they make this kind of, there's this kind of saying things get done in the amount of time you give them to be done, you know? So one of the pieces, or both of the pieces I'm going to show you tonight took months and months to develop, but you know, the work we did there came together in 2 days. But we've been developing this, which I think is maybe what you're getting at, is this tool foundation since 2016. So it's about 5 years now, and so at this point we have a pretty reliable tool set, you know, and so we know things are going to work. You know, it's not like much of a mystery, and when things are going wrong, it's like, you know, it comes down to a few simple things, you know, like rebooting your computer or whatever, and so
always works.
Yeah, and so that's kind of where we're at. So, and that allows us to move from the kind of technical and the engineering side to creativity pretty quickly.
Amazing. And you've been working there for 6 years now to these tools. I'm looking forward to see the presentation and see, is this open source, by the way, or does it use specific technologies? Is it general purpose?
Yeah, we're still kind of like, nothing's really fully public right now. And I think how it's going to roll is some things will be open source and some things will be closed source. And so we're just trying to figure out what that right balance is, you know, but we're very much interested in engaging the hacker community and having tools that people can really adapt and modify to their needs as needed. So.
That's what everybody is looking forward to see. So you do have a presentation about your the topic that we mentioned. Would you like to share it with us?
Yeah, sure. Okay, here we are. Everyone can see that, right?
Yes.
So, okay, yeah, I think I can see what we see. So there's one more window I need here. Okay, perfect. Anyway, so yeah, the collaboration I've been talking about is we call it PACIS, which is performance art and cyber-interoceptive interfaces. So I'll kind of break that down a little bit. So performance and art we get, right? And I think there should be a comma there. That's okay. And cyber, so when we say cyber, we're referring to cybernetics. So not just, I wanted to invoke that term because not just think about biofeedback systems, but actually to think of like cybernetic feedback systems, and in the sense that these are systems that are adaptable, and so as they receive information, they don't just present the information, but they actually adapt to it and change to what's happening. And there's of course this whole like field of cybernetics that's drawing from kind of philosophy of systems design. And so interoceptive, which is a term you were bringing up earlier, Chris, is this term about, I guess the simplest way to explain it is being able to listen to the inner workings of the body. So there's a lot of parts of your body that are voluntary and involuntary, and some that are both. And so what we're dealing with is we're dealing with performers who have the ability to, through a practice they call somatic practice, to learn to listen to the inner workings of their body, so their digestion, their skin temperature, and then can hear their heartbeat, being aware of how they're breathing, and really being aware of their physiological state at any given time. Yeah.
Is this part of a training of a performer?
It's very common practice nowadays for performers to be involved with these somatic practices, which involve techniques drawn from like yoga, Feldenkrais, or even like Tai Chi. So like meditation. So a lot of things that involve very like disciplined connection to the systems of the body.
Interesting.
And so this is where our collaborators, Erica Batdorf and Kate Digby come in. They're the performers, and then Alan Macy is my collaborator. I know him from Santa Barbara, and I'll get into that story as I move on. So the whole thing kind of started with this project called Burnish, which was created by Erica Batdorf. And I was involved with the technical development. Here you can see a little bit of my architecture influence because I designed this tent. So I was like really involved with like the technology, and I designed this tent and built the sets. And then there are a couple other artists involved who were involved with like there's an artist who made the mask, who's from Indonesia, and so on. And so Erica is a colleague of mine from the faculty, and she became aware of me through, actually of all things, through a committee, and that we were both on. And she said, well, I have this project, and I think it would be really interesting to work with you on it, because I really want to have work with digital technology. And so as part of anytime I want to collaborate with someone, I always have lots of questions about them, like, what is your practice? What are things you think about as an artist? And so she started talking about her somatic techniques. And one of the things I found interesting, the way I would describe it, I don't know if she would describe it this way, but it is, in method acting, which we've all heard about, is really about trying to embody psychologically the state of your character. And we, famously or infamously, we've heard about actors who, take that too far, and they become the character all the time, and all this thing. It's very much what you might consider like a Freudian approach to acting. And so in kind of contradistinction to that, what Erica does is she actually thinks about, rather than the psychological state, I mean, that's important, of course, when you're thinking about any character, but rather than trying to embody the psychological state, she's trying to embody the physiological state of the character. And so really thinking about that how she's presenting the emotion rather than trying to become the character. So meaning that, like, if she's going to be angry, she's going to raise her skin temperature, raise her heartbeat, and then like several like kind of like physiological things that go with that. And then but psychologically, she's not angry at all. And actually what's going on in her mind is she's thinking about, like any actor would, what's my blocking, what's my next line, all these things. So it's something she calls juggling. So you're kind of moving through somatic state, lines, blocking, what's going on, and then back to somatic state. And so you're kind of rotating between this constantly. And so this is what I would describe as a kind of virtuosic understanding of your somatic system. And so in this piece, I think it's also interesting to talk about this piece because it also conceptually relates to how we approach our work. And so what she's doing is it's a tent, like I was saying, and it's designed to be a performance for one person. So the audience member puts on headphones, and then there's a kind of reading. So you're asked these questions, and here you're being asked to choose a picture, and then she puts out these cards and she says, choose something to burn. So there's this kind of like theme of like releasing these kind of like what it could be trauma or negative emotions or things
almost
that
like
burden
Burning
your
Man.
life. Yeah, exactly. Yeah, exactly. So you're kind of burning away, and then you choose a color, and there's these boxes there, and depending on your choices, the performance is different. So everyone gets their own unique performance, and she makes a gift, and it's really about, you know, connecting to someone in a really intimate and personal way, and it's like connecting with an audience in a way that really is almost impossible to do with a larger group of people, you know. And so having this deep human connectivity. So anyway, going back to the whole thing about the physiological expression, what I found interesting about her practice is when I've been friends with Alan Macy for quite a while, and he's a biomedical engineer, is talking about, and an artist, I should say, or emphasize. And I would ask him, and quite a few times, I'm sure everyone asks him, but what is emotion? And we'd talk about, you know, well, and I've seen some comments along these lines in the chat here, and it's like, well, there's emotion, and there's these things that go on, you know, psychologically and physiologically with your body, and you interpret those as feelings. So this is, I'm feeling angry and this sort of thing, and then there's this kind of affect, and I think we can make some kind of distinction between that, because arguably, you know, the affect's what we can measure externally. So we can say, you know, like I was saying, if your heart rate's elevated, your skin temperature is elevated, things like that, your pupils are dilated, these can be indicators of physiological states that correlate to an emotive state. But how exactly you're interpreting what you're experiencing is more or less subjective, and the only way to know that is to ask the subject what they're feeling.
It's almost like you're measuring some proxies of emotions, but they were generated inside the individual, and you don't really have that circuit to tap into the emotion of the individual, but you can measure this. Can we call them external proxies or body telemetries?
Yeah, exactly. And so we can measure those. I mean, and I guess another way to look at it, I mean, there's in the whole mind body thing. I mean, it's really kind of arguably not one or the other. And I think it was William James who thought that you're experiencing emotion before you're actually interpreting it as an emotion. And I always feel embarrassed talking about stuff like this in front of neuroscientists, but that's okay. But, you know, there's also this latency in the body. So things happen, your body's reacting, and then actually your brain, as much as 100 milliseconds later, is then making an assessment. And that goes with emotion too. So you're actually, like, your body's engaging in an emotive process before you're even thinking, I'm feeling that. And that's really interesting too. So this whole thing being mind, body, and where you are, and one way to look at it is we're kind of, there's all these systems of the body, and they really happen all these different cycles. So we have like monthly cycles and daily cycles, and then hourly cycles, and like the digestion. So kind of like moving up the spinal cord and
hormones.
into like the heart and the lungs. You know, where you start getting into like rate of like, you know, four times a minute to 60 beats per second, and then into the brain, which is really high frequency, you know, and all these things are, you could think of them almost like on an ocean, and you're kind of floating on that ocean as you go. And I'm totally stealing this from my collaborator. That's okay. That's part of collaborating. But one thing my collaborator would say is like, well, one day, you know, you wake up, or the one I like to see, you write a letter, right? You're going to write a letter and you're really angry. You're angry at your girlfriend or boyfriend or whatever. And you actually say, well, actually, I'm not going to write the letter today. And then you go to sleep. And then you get up and you want to write the same letter, you're going to break up or whatever, but it just comes out totally different, you know, and a lot of it just really has to do with this kind of physiological sea that we're riding on constantly.
So can I ask a question at this point, because it raises an interesting point, almost as if the emotions, they are not the interpretation made by our conscious, but they are the telemetries that you're measuring from the body, because they are generated in something measurable within the body, in the mind-body axis. So if you were able to measure, for example, skin temperature or respiration of heartbeat, would you also be able to control them at some point? Because if they represent as a whole picture your emotional state, would you think it's going to be something that, you know, in the cybernetic paradigm that you were showing, that is something that could be closed loop at some point?
Well, I guess the way I would look at it is the body is a cybernetic system, and I'm not sure. I mean, from the things I've been reading, like Descartes' error by Antonio Damasio, and you know, I'm not sure if I believe anymore that there is much difference between the mind and the body, or really that the brain ends in the head. It seems to extend through the spinal column, and you know, and that it's so to say it starts one place or the other. It's really kind of, you know, this more of this feedback between the two systems, and
yeah, but
they're
what
really
can you do with
on
machines? Can you just intercept the pathway and then do something with an external machine, control emotions, or once you measure that you have a state or you are in a certain state, can you intervene and change it with a machine outside the body?
Right. Well, that's interesting. I mean, I think we do that anyway. I mean, arguably, like if you watch a film or you listen to music, you know, and you know, there's all kinds of ways we can alter our affect. But what can be interesting and also extremely dangerous, arguably, is that we can create systems now that can make an assessment of your affective state, and then actually, you know, supported by AI, this can get increasingly accurate, you know. So
yes, correct.
So I mean, one side of it. So one of the ways I look at this work is that as artists working with technology, is that we have this opportunity to critique the technology that's coming out, you know, and the technology that's around us. So the reality is that, you know, although I think it's not that common. I mean, it's there are other artists working in this area, obviously, but it's not that common. That this technology is ubiquitous in things like Apple Watch and you know, and various kinds of camera tracking and things like that are going on by companies that, you know, they're trying to learn things about you. So like Apple Watch can track your sleeping, how many steps you've taken per day, you know, and so on and so on. But, you know, just simply by measuring your heart rate from the watch, it can actually do, I can explain this as we go on, it can do emotive assessment of your state.
Mm-hmm.
And then that could potentially be used to manipulate you either, you know, in products you buy or political opinions, things like that. And so one of the things that we're trying to do is think about how can this technology be used actually to connect us together? So another thing that is a trend in like commercial technology is this trend towards dissociation, and COVID has actually really hasn't helped with that. It's exacerbated it completely. So we have so we're all spending all day on Zoom and so on. There's very little human contact, and but even before that, you know, there's a lot of people who are connecting almost exclusively on social media, and you even see people who are walking down the street and they're, you know, they don't look up from their screens, and so we're trying to think about technologies of association rather than disassociation to kind of counter that trend, and using things like interception, somatic awareness, human connectivity to do that.
Wow, if you have this power through art, I'm really very interested in how these mechanisms are put in place. If there is a school that teaches this, or there are courses, I think this is extremely actual.
Yeah, well, I think it's you know, like many things in art, it's technical and we try and be very accurate, but it's also speculative, and you know, we're probing maybe in ways that we're not asking easy questions, I guess. So I'm not sure it's codified in a curriculum yet. I guess that's the way I would put it.
I think that raises a lot of interest. At least I am interested, and bringing a positive impact also in mental health, let's say mental wellness, or these new acronyms and keywords that you hear about nowadays about how to improve mental health due to COVID, dissociation, as you put it. I love the term dissociation because I feel dissociated due to this COVID pandemic. And bring people together through performing arts or through some sort of instrument that you can measure and then you can talk about. It sounds very systematic.
Yeah, maybe. So I could show you a couple things, and I probably won't get to everything I prepared, but that's okay. It's better to prepare. So kind of moving on in the story. So Burnish was in 2015, and what I didn't mention was Erica, when she approached me, she said, oh, I have this project, and by the way, it's premiering as a collateral event at the Venice Biennale. And so I don't know if you guys know, but so we were part of this group show of 30 artists at the Venice Biennale, and I had such a kind of quiet, small role. I felt like a fly on the wall, but it was still quite an auspicious beginning. And so anyway, so yeah, based on the conversation I described, I introduced her to Alan, and then at the same time, she introduced us to a collaborator named Kate Digby, who you can see here in the, I don't know if, can you see my mouse?
Yes.
In the blue sweatshirt, and this is Alan. And we had this week, we decided to kick off our collaboration with a week-long workshop called Movement and Emotion as Computational Interfaces. And why we have two names, I don't know, but that's how it ended up. So just to confuse things. So what we did was we brought in movers, performers, people who studied with Erica and Kate in this deep somatic practice. And we brought together artists who are working with technology, and just kind of, and so for that we had to develop a suite of tools just to make the workshop work, and just to see what happens. So for example, like in this project, this is all about facial expression. So you measure muscles on the face, so the corrugator and the zygomaticis, which deals with frowning and smiling, and they did a performance around that to kind of like manipulate a video which is behind them of I believe Charlie Chaplin or Buster Keaton. And then there is work done with electoral dermal activity, heart, and then this machine here, in case you're wondering, is called a dream machine, which uses something called flicker phenomenon to stimulate alpha waves in the brain. And so we're kind of like playing with everything. And that was really foundational. That's where our foundational tools came from. And so really at the core of what we were doing is this device, which looks kind of funny, but it's an educational tool produced by a company called Biopack, which produces non-invasive biopotential sensing systems, and then software to support it. And it's mostly used by academics. So probably many here listening have used Biopack or are familiar with Biopack equipment. And this particular device, it's called the Biopack Mp40, which is part of the Biopack Science Lab, which is you can buy like arrays of these and for use in the classroom. And one thing that's interesting about them is so it's a data acquisition unit. So that means that it doesn't do any analysis. But what's interesting is it does its data acquisition in the audio domain. So that means that we could actually use something like, this is a screenshot from a software called Max MSP. And you can see the acronym MECHI here, which is movement and emotion as computational interfaces. So this is a Max object we created that analyzes ECG signals. And from so we're doing a high level analysis. So we can get a raw signal, and then we get something that's we call a Cook signal, which basically produces a unipolar pulse on the R wave. And then from that we can derive R to R. And then we can do beats per minute. And then we can actually follow the amplitude of the R wave to derive respiration and respiration rate. And we can also do respiration effort can be derived from that as well. And then from that, what we do is we do a standard deviation on the R to R and do a heart rate variability calculation.
Amazing.
And the reason this is important is we're using heart rate and heart rate variability to assess subjects, I guess is the best way to put it, valence and arousal. So what you see here, this graph here is called the Russell Circumplex model of affect. And this is something that was published in 1980 by Russell, forgetting his first name, sorry. And basically is this idea that, that emotions, and of course there's other models, and there's I don't think I'll get too into it right now, but there's a three-dimensional version of this that also deals with challenge and threat. And but basically the way this works is arousal obviously can be mapped to heart rate. So the higher your heart rate, the more excited you are. And of course, there's lots of problems with that, because if you do lots of jumping jacks, your heart rate goes up. There's ways to account for that by having doing a tonic and basal calculation on the heart rate, things like that. But that can be tricky. And then heart rate variability is mapped to valence. And the way that works is, if you're in a fight or flight mode, what tends to happen is your brain will take over the systems of your body. And so like if you're, almost got hit by a car, or you're about to get in a fight or things like that, your brain says, okay, we might need to go into action. And then what happens is the systems of your body just immediately become like a metronome. And so your heartbeat becomes very heavy and regular, your adrenaline's going up, and your heart rate variability basically drops to like 0, right? And that's important. And this can also happen though when you're stressed or you're unhappy, and you're basically in these negative affect states. Your your brain is kind of taking over more. But when you're more calm, more relaxed, more meditative, your heart rate, your heart actually, and your other organs, the brain lets go, and you kind of you drift, and your organs are in a mode where they're more like self-regulating, and so so that's when your heart rate variability goes up, because you're actually kind of more drifting. You're on that sea I was describing.
It's almost like the cybernetic state is free of fluctuating in response to external events, relaxed, ready to take in the inputs. And that's part of this cybernetic allostasis, I guess, of having all systems ready to variate a bit in response to external events, as opposed to, you know, the state of stress that you're talking about.
Yeah. And so that's more or less how we do our assessment. And I keep these charts around. And actually, we have a way of tuning these to individuals. So especially, you know, the heart rate variability is tricky because if you look over here, you know, it changes with your age. So if we don't know the age of the subject, it's kind of hard to know what's normal range. But also, performers tend to be more athletic. So someone who's like, I won't reveal Erica's age. Let's say it's somewhere in here, but her heart rate variability is a little more here because she is more athletic and healthy and that sort of thing. And so it's ideal if you can tune it to an individual, and so that works well for performance. But I also do installation art where you have people walking in off the street, and it can be tricky to do readings off people who are just walking off the street, or at least on this level. So the other thing I'd say about this real quickly is you might notice there's a dial here, and and so this stupid little device, it's not that stupid actually, is it can do ECG, EEG, EOG, I don't know if I said EEG, EDA, RSP, so really full range of biopotentials, but only one at a time. And so we have made tools, you know, the most common we use are EEG, EMG, and ECG, but we've made tools for all of those different kinds of readings. And then I do a lot with physical stuff. So I have like one of the projects, this was conceived of by Alan, but is this idea where you would hook someone up with the ECG, and then you have this prosthetic heart. And it's actually important. We could make this wireless, but it's actually important that it's all connected with wires. And the heart lights up and has a haptic motor in it and pulses with the person's heart who's on the ECGs. And then we pass that around. And the way this is used in kind of more ceremonial performances, and it can be very intimate and you know, like deeply personal. And this is a kind of a primitive prototype of this, our current version of what we're calling the PACIS interface, I guess is the way you look at it. So this is so the Mp40 is still used for data acquisition in the system, but the system's used for analysis. And no, that's not an ECG. I just took a picture while it wasn't hooked up to anybody. But on this little device, you can do all those different analysis I was talking about. So the R2R, BPM, HRV, RSP, everything. And then we can adapt this also for EEG, EMG, or whatever.
And this is a device that is similar to the previous device, right?
Yeah, well, this one only did EEG, or ECG, sorry, I'm getting my acronyms mixed up. This one only did ECG, and this one can do anything, basically. And then what's cool about this is it also transmits the data over Wi-Fi. So you can wear this. It's battery powered. It's got a LiPo battery in it. And what we're making this for is Yeah, thanks for helping me out with the acronyms there. What we're targeting this for is artists and makers and people in the humanities. People don't normally have access to this kind of knowledge and equipment, and so and seeing what can happen.
So this is obviously to record telemetries from the body. What's the output?
So that, that really depends on the user. So we do a lot of like oralization and visualization of it through artworks. And so I can give you an example. I was going to talk through this piece, but so this is a piece we did that was like a Zoom-based piece. And here you can see, so we're doing an emotive assessment of the performer, and she's a bit in an intense state, as you can see. And what happens is in the beginning of this performance, she more or less interviews the audience. And it starts off seeming really innocent, like an innocent conversation. Then she starts asking questions like, how are you feeling? And that drifts into, can you hear that, or can you not hear that?
We can hear it very faintly.
Oh, okay, that's perfect. It's too hard to talk over otherwise. But and then what she tries to do is go on this emotional journey where she's following kind of the path of the conversation before. And then at the same time, we were grabbing phrases from the audience, and we use that in a poetry generator later. But at this point, she's reciting a poem, and then there's this orb that's in a kind of more expressive way, expressing her valence and arousal and heart rate in this object. And then you're also seeing it more like, let's say, clinically on the side at the same time.
And is there a meaning for the colors?
Yeah, so we simply map the valence and arousal to the spectrum, so from blue to red.
Understood. So by moving left, the valence becomes blue, negative valence.
Yeah, exactly.
And the cloud of points that you see visualized on top of the orb, is this something related to cardiac activity?
Yeah, so they yeah, they're kind of pulsing out with the heart rate as a way, or with the pulse of the heart. And then so this is a bit. So poetry is a big part of this piece, and there's a lot of reasons for that. But one of the reasons is poetry is a good way to express emotion, and it's a kind of art form that is, although it's from language, it's beyond language in a way, and because it's more illustrative, it's like word painting, and so it's open to interpretation. And so what's going on here? This is at the beginning part that I was describing, and someone saying we're all part of something that's happening. And then later in the performance, this comes back later. So as the performance starts to climax, the poem she recites is coupled with the phrases that the audience is saying, but then an AI is reading what the audience is saying and completing the poem. So it's kind of a poetry game, and so that's what's happening here. And so the whole scene starts to become, in the climax, like painted by her affect.
That's very interesting also for the audience. And in fact, we do have a couple of questions, if you like, Mark David.
Yes, yes.
I do have a question from Alfredo. He asks, how many valence states can be mapped using the HRV technique, heart rate variability? Can everything be labeled on the graphic, can be shown as a name individually?
I'm not quite sure how I understand it. I understand the question. It's really, the way I look at it is it's a gradient. And there's a lot going on here. Like it's like clinically, this is a nightmare because you have someone who's moving, and so that's affecting the heart. You have, and then they're using somatic practice to actually alter their physiological state. At the same time, they're in a physiological state that's inevitably like nervous, and it's well, I'll give you an example. So I did a kind of like VJ DJ performance about a year before this premiered during COVID, and using my heart rate. And what I noticed was that when you're DJing, you're about to like make a change or something, and I could actually hear the change I was going to make before I made it, because my heart rate would change really drastically as I'm making that decision. So it was actually really good at like predicting the moment before I actually made a decision. And so there's a lot going on there. I mean, I'm not sure if that's actually exactly answering the question, but I would think of something more fluid. So we use these kind of adjectives you can see on the top, like I grabbed these from a thesaurus, but like I am anxious, I am enwrapped. And the reason we're using them is because you're really in a zone, and in the end it's like every individual is going to interpret 0.37 and 0.59 differently, and it all might depend on your circumstances. It also depends on like the 5 things that happened before you got there, how you might interpret that particular physiological state.
Well, it seems to be very accurate, at least when it comes to depicting positive emotions. And I think that's the power of somatic actor, if you can call it like this, to transfer like her willpower to represent physiological states. Like you say, that there is a link between physiological states recorded by telemetries and your state of mind. So if an actor is able to control that, that's quite remarkable. And it seems like by looking at very briefly at this performance and looking at the color of the dots moving, at least around the valence axis, it seems to be quite accurate. And I was wondering if there is in the background there is some calibration due to what you said about heart rate variability.
Yeah, absolutely. So she spent a lot of time doing self-assessment. So one of the things I didn't mention is in her process in this piece is we use something called the self-assessment mannequin, which is let me see if I can find a link to that. And it's a self-assessment tool, and that there's different versions. Let's see if this is. I don't know. I have to poke around. Okay, thank you. Yeah, I'm sure someone can find it. And it basically has this kind of gender neutral character that's showing more or less arousal. There's an iconography for arousal and an iconography for valence, and then another one for dominance. And the idea is that she's reading her biophysiology and doing the self-assessment mannequin, every once in a while, and then thinking about her state, and then we were able to kind of from that figure out her range, like her range of heart rate variability and her range of arousal, and then that's what we plugged in, and so that's why it's, I think, more accurate than
it's almost like neurofeedback. You do tune your emotions to your telemetries. So in fact, probably the responsivity of your emotional response, your emotional response change and is more accurate when you decide to control it. I guess, if if you close the loop with the neurofeedback training that you were talking about, if we can call it like this, probably artists are very good at maybe controlling their own heartbeat, or is that even possible?
It is. I think people do. There are people who have the ability to control their heartbeat. Actually, in some ways, anyone can do it. So a simple way to do that is, I think we lost John.
I will invite him when he comes back.
Yeah. So a simple way to do that is really to take like 3 or 4 deep breaths, and your heart rate will drop pretty quickly.
Can you control also once you're performing, given the impression that, like the DJ session that you were describing before, is 2 ways, right? You can use your emotion to control the telemetries, but you can also change your telemetry or your, maybe muscular tone to change your affection state. Is that possible?
Yeah, or at least your physiology and the way it's presented. I mean, this gets in the whole realm of somatics. I guess that's the way I would answer your question. So it's like people are doing that constantly through like, yoga, meditation, and all, all these various techniques.
That's impressive.
Exercising, actually, you go on a run, you're increasing your endorphins, and so we're doing that all the time, and we actually do it also with like caffeine, and whether we sleep enough, and
Yeah, I think that's a very interesting point on how much being in control of your body through sports can facilitate. You were talking about bigger or larger span of your heart rate variability if you're an athletic person, how a healthy lifestyle or exercise can influence your ability to control emotions, because you have a bigger range of response, and in a cybernetic state and sense, you probably have this range of control that is broader, and that probably reflects also on the mind-body axis.
Mm-hmm.
And it's amazing to speak about how systematic and how much science there is behind performing hearts, right?
Yeah, exactly. And we're talking a lot about art and technology, and I'm talking about coding and engineering, but there's, like you're saying, there's this technology of the somatic practice as well, which is actually deeply researched and well thought out.
Yeah, and on this account, this technology more on the hardware side. Before leaving us, John, which is going to reconnect soon, I hope, he was asking a question about the device that you used, and it was, I guess, the second device that you used, the PACIS.
Yeah.
It was asking what is the physical size of the new device, because I haven't seen it mounted on the performer, on the dancer.
So I have it here, and again, it's not doing an ECG, but yeah, so it's about this big, I guess. So,
Yes.
I have a scale here, so it's a little less than 90 millimeters. So, across, and then so it is a kind of bulky system, but and I won't get too into comparison to other products, but let's just say we can do a very, very high quality and reliable signal from the data acquisition unit from Biopack, and that's like, that's a medical quality device, and it's like properly isolated. There's all these like considerations whenever you put things on people's bodies, so you want to make sure they can't get electrocuted, things like that. So the hardware isn't raw. There's a reason we put it all in an enclosure, and then So, you know, you ended up, at the moment, you end up wearing 2 devices, but I think eventually we're going to get them all into something, a single board. But we're working on right now a lot with off the shelf stuff, you know, so we're, and it's just efficient, you know, and then eventually we'll probably roll our own, you know, but that's a whole nother, as you probably know, Chris, another layer in this kind of development. And
what is the kind of maturity level, let's say, in your analysis approach on the signals? I mean, I know you mentioned that. Well, I know you had the diagram a little while back on the slides, which was cool, and like some of the high level structure. But like, do you feel like you have the basic toolkit or the basic analysis kind of suite nailed down, and there's really nothing else under the sun to be added, or is it kind of constantly evolving? What's the dynamic there?
I would say what we have is foundations, you know, and where we're really fleshed out is in the ECG, because that's where we've been focusing most. So, you know, we're like in the EMG, there's some things you might want to do, like mean and median frequency. You know, we're still trying to figure out the best way to do that. EEG, you know, like right now I think I mentioned, we're mostly looking at like the ratios. So there's like the beta theta ratio and you know, the sort of things that deal with concentration, meditation, or, you know, and then we can do basal and phasic analysis on the EDA, which is really important. Otherwise, it just looks like a drifting feather. And you know, so it's a really foundational. But then what you do with that, I think, is really where the exploration is, especially from the point of view of the artist. Like, you know, how do we visualize that, and how do we visualize that in a way that's meaningful? You know, do we? You know, one of the questions I have is like, how can we get away from that? Always hearing the heartbeat. I mean, it's very powerful, but sometimes it'd be really nice to like have a more of an abstraction, and the more abstract you get, you start to lose that meaning, and so it's or that you lose that anchor where the audience understands that you're measuring the heart, and it's already like pretty weird because we're not used to listening or seeing representations of the internal processes of our body, and you know, so we don't intuitively see them, and you know, so I think those that is really kind of where the fun and the exploration and the mystery is, you know. And
do you have like a general take on sonification kind of abstraction levels, or kind of somewhat kind of echoing what you just said? You know, there's lots of great tools that you see from time to time that like take your EEG data, make an awesome kind of semi-automated visual display, for example, or some kind of semi-automated, slightly tuned for maybe like major pentatonic scale sound sequence, right? But the thing is with all those things that there's like the amount that, say, the sonification part, or like in some sense it's either like conveying a biosignal or representing a biosignal, like playing that role artistically and conceptually, right? And then there's what you're doing with it to generate something that's like aesthetically appealing, and then the percentages between those two things. And if the I don't want to use the term artistic license, because obviously the artist has all the license here, but the kind of setting things up to say sound nice in terms of like tonal structures that maybe you assign in certain ways, you've kind of done all the work there, right? And then there's not much work for the actual signal to really do. So like you could give it random noise and you'll get like gripe or like general sense when I see like sonified or other, you know, computer like represented or artistically represented biosignal things, is like trying to strike that balance in a way that feels like it's hitting the right balance?
Yeah, I guess my answer to that would be that I'm focused a little more on process and systems than things like that. Yeah, I don't know. I mean, I wonder. I mean, I know I've bought. I've worked with a couple of EEG headsets in the past, and like the NeuroSky, which is really quite excellent, actually, I think, and another one, but some of the software that oh, Lucier is a great reference, by the way. Some of the software, yeah, it feels a little hokey, or strange, or and yeah, I don't know how to comment on that. I mean, I don't want to make too much of a value judgment, but let's just say is on a different approach. Like, for example, I was showing those heart, that's called the Hand and Heart project, and it's not just about like holding this prosthetic heart, which I actually have one here, in your hand, but it's about really that experience. So how you set it up. So it's like, even like putting on the electrodes and the electrode leads, it's like ceremonial. So it's like taking communion or something, and it's this process, and you're doing it together, and you're kind of exposing, not, I don't mean in a nudity way, but you're exposing yourself, and you're exposing something that people can't normally see, and then it becomes something out there, and then you're giving it to others, and you're sitting in a circle, and and sound is really important to that, and so it's a quite literal representation in a lot of ways. Like it's pulsing like 1-to-1 with the heart, and the light is pulsing 1-to-1 with the heart, but in some ways that's much more beautiful, I think, than like trying to make it a pentatonic scale or something like that, and the other thing, like with the brain, what I've been interested in is, I was describing a little bit, but that dream machine, which is a device that was developed by an artist named Brian Geisen, who is a Canadian, reportedly Canadian artist who didn't want to admit he was Canadian, but he had a couple of citizenships, I think, and he was a close affiliate with this writer named William S. Burroughs. If you're not familiar with him, was like one of the main writers in the Beat generation, and it was this. It was inspired by a book that Brian Geisen read on neuroscience, and that came out in the 50s on the brain, and it described something called flicker phenomena, which is kind of an area of research that's been going on since the 1920s and still going on. And basically, if you flash a light at around 100 hertz, and you can have your eyes closed, you can stimulate alpha, higher alpha activity in the brain, and you can, and if you couple it with the sound, even better. That's at the same rate. And but what's also interesting about the Dream Machine, the reason it was called, so is this tube, and I think there's a link there, and it has these holes in it, and it was meant to be put on a phonograph, and then you hang a light down in it, and as it spins, the light flickers, at the right rate, and then when you close your eyes, the way I interpret what's happening is your brain can't really understand what's happening, so you start seeing patterns. It doesn't really interpret the light, the flickering.
Is it like entrainment?
Well, the entrainment's something else, and that's something we play with too. But it's like I'll get to that, and but you see these patterns, you start to actually hallucinate.
Like kaleidoscopic lights?
Yeah, without being high or anything. And so that's why they called it the Dream Machine. But one of the things you can do with flicker phenomena is once you lock someone in alpha, and you need an EEG to know that, you can rapidly change the rate of the Dream Machine and throw them into a dominant theta. And then they will be dreaming. And this is from research papers that I've read. So it's from I have a pretty good paper that does a survey of flicker phenomena. And
do you remember the name of the authors?
No, but I could try and dig the paper up and share it with you.
Sure, that would be interesting.
And yeah, as far as entrainment, so this is where we try and synchronize various kinds of physiology among different people. And actually, the research shows like one of the easiest ways to do that is with singing. So when people sing together, their hearts start to sync.
But also you can entrain the brain waves.
I don't mean 1-to-1, but the rates are similar.
And, yeah, that's across individual synchronicity, but also you probably can use the same word for entrainment of a light pattern with the brain.
Oh, I see what you're saying. Yeah, I'm sorry. Yeah, that makes sense. I've never heard that term used in that context.
I guess it
makes sense.
It can be used both ways, and then we're throwing jargon here, but I understand this is important also at the level of the communal experience on singing. And I would be really interested in knowing the order of that flicker phenomenon. I tried to Google it while you were talking, but because as probably you don't know, but this I think there is a product called the Pandora Light. I think it has a set of LEDs mounted on this lamp, in fact, looking downwards. And these LED are RGB LEDs at a certain power, emission power of lux power. And people literally lies down under the lamp and with the eyes closed, and this lamp is used in therapeutic sessions, if you like, because we didn't mention that. We mentioned only the entrainment effect and the opportunity to relate light patterns to beta, alpha, and theta rhythms, but we didn't mention the long-term effects of light therapy, right? Because it could be used, for example, in certain cases for meditation, but also in certain cases to change the Alzheimer's disease state, like chronic diseases. So it has long-term effects. So that would be interesting also.
That's the promise.
Yes,
that's the promise. We're all looking forward to see if that works.
Yeah, there are a lot of
photobiomodulation for Alzheimer's therapy.
Totally, and then you have many other ways of doing that, like infrared, nasal through the nose. So light therapy is a big topic now, neurostimulation, and you touched upon this from your field, and it's extremely interesting because it applies, in fact, to the brain, and then I like this discussion because it brings about many other fields, right? There is a lot of contamination between art, brain sciences, performance arts, psychology, technology, and I love this discussion. And by the way, there is another company that has these goggles. So LEDs are not mounted on a lamp, but they have goggles that can be worn. Actually, I can give you a reference later on. And basically with your eyes closed and this device, I experienced this, what you say, this stroboscopic, kaleidoscopic effects. And I tried it in Berlin when I was there 2 weeks ago, and it helped me out with the jet lag.
Right. Okay. Yeah, I've read that about stuff like this. Yeah.
Yeah. So you can think, you name it, right? There are so many applications, and thanks for bringing this about. And you call it the flickering machine, right? The dream machine.
Yeah. And there's a great documentary about it, I think, called Flicker, which is totally about the subculture around it. I have the link here. So it's got people in it like Genesis P. Orridge and Iggy Pop, and total of the fringe,
Yeah, that's great, and people would like to reach out to you, and people ask if it's possible to reach out to you, and in which form it's possible to reach out to you.
Easiest is by email. I don't know. Is it dangerous to give email in this context, or
Not for
Facebook?
this. Let me see.
Facebook might
I guess
be safer.
you can share your site, one of the links before, and then probably it contains already the email, right?
Yeah, exactly. And then I'm also on the Facebook. I'm not on a lot of social media. I'm reasonably paranoid. So.
We're talking about dissociation.
Probably the worst.
We didn't say, but John, you also work in a similar field with measure of. I guess you were telling me recently that you were measuring brain activity related to oxygenation states of the brain, and this could be related to portable devices also to measure performance, right? It has to do with light technology.
Well, actually, the closest thing to the things we were talking about just now is so yeah, we're doing stuff with FNIRS, some new FNIRS work, which is functional near-infrared spectroscopy. So that's like LEDs and lasers shining through the skull to measure blood flow. Mm-hmm. But what's actually closer to some of the stuff we were discussing just now is the other main thing that I work on, which is brain stimulation. And we think a lot about oscillations and rhythms. So I'm super interested actually by the thing that you said just now, Mark David, which I didn't know about, which is that the of a flicker, visual flicker, you said is like enhanced if you have a synchronized. Does that ring a bell? So, and just generally speak, oscillatory stimulation to the brain and activity. So that could be visual stimulation. More often we think about magnetic and electrical stimulation. But there's a lot of interesting stuff you can do in the auditory and visual domains. It's a lot easier to do stuff in the auditory and visual domains than to apply large magnets to people's heads. And the interesting thing from I think a neuroscience point of view for me is this kind of question is between driving and resonance, right? So you have endogenous rhythms, alpha rhythm, theta rhythm, maybe beta rhythm. Like there are other rhythmic behaviors there, but you can blast the brain with really fast frequencies and kind of just and essentially like imprint it. That's what a steady state visual evoked potential kind of is. Or you can choose the frequencies that are more like the brain's natural resonant frequencies, and then you're not kind of so much imprinting, but you're more like enhancing an existing rhythmic pattern. And that's, I think, a more interesting thing to do. But depends what you're working with. Like visual phenomena, visual flicker phenomena, they have their own characteristics. Like certain things just don't look flickery enough at certain frequencies, and some of them you can't even see the flicker because it's too fast, right? So
right.
I guess it has to do with the fact that as heart rate variability has an individual component, the brain also is individual in their ratio of alpha, beta, theta oscillations and amplitudes and responses to external stimuli, whether they are audio or video stimuli. And I guess, and probably you have not shown that yet, but maybe you do have a couple of electrodes also on the scalp in your performances, Mark David. And ideally, on the same line of thinking of what John is speaking about, if you could measure and at the same time show those lights according to the online real-time response of the brain or the heart or whatever you are, a real-time system, it could be advantageous, for the, tuning and calibrating to the specific individual, because at the end of the day, this magic box that you showed us, it could be a closed loop system, right? Where you don't close the loop only by presenting the stimulus that is reading out something, but also you modulate that stimulus intensity or frequency based on the current state of the brain that you acquire in real time. And then, I think that there will be actually the so-called closing the loop of human-machine interfaces that is so much advertised nowadays in the field, and also in neurotechnology at NeuroTechX as well. And what are your comments and feelings about this closed loop system approach?
Well, I guess I'm not. Maybe I don't follow exactly what is the difference, I guess, or maybe I was a little bit lost. So, I mean,
I guess the difference is that the heart is a muscle.
Yeah.
And in your heart rate variability and transferring to valence states is pre-calibrated, so it's a static acquisition due to training of many hours. But if you were to acquire it during the performance, it will be kind of more responsive, right?
I get your saying. Yeah, well, I mean, it seems like it's totally possible. It feels like, I mean, I've heard about some products like, the more popular ones, like that do EEG and stuff. I mean, what they're doing behind the scenes is they're collecting a lot of data from their end users, and it may be animatized, but then they're using that to train their systems, and that's how they're able to, like, with really low resolution hardware, get pretty good results. Because normally with the EEG, like, there's a number of products out there that only have like 1 or 2 EEG sensors, and and arguably they're not that great actually, but sorry, no offense, hopefully. And I mean, let's say not that great in comparison to something like that has 16 sensors or 32 when you start getting those like higher order, because you can't really locate where signals are coming from unless you have multiple sensors. You can't, things like that. So it's but so to get like more complex, meaningful things, like the way they offset that is through AI and lots of data, like becomes a big data problem rather than and so for that, it's much easier to do something like you're describing, where you don't need to train in advance, to get more meaningful results.
Definitely an idea I'd like to contribute to for the future. And we also have another question from the audience for you, Mark David. This is from Richard from OpenBCI, and he's asking, what kinds of audiovisual experiences would Dr. Hosale like to see more of in the future, and how can others expand upon the work he has done?
Well, I guess one of the things. Can I just make one more comment on that closed loop? Is I think either way you're going to need about 3 or 4 minutes at least, and it depends on the system, before it can calibrate, because how else will you know? So it's going to take time, before these algorithms can sink in, even with a lot of AI and stuff. I just don't see how you can avoid that. It's not going to figure out your heart rate variability in 2 beats. That actually
it's a huge topic.
Minutes. Yeah.
Oh yeah, it's a huge topic, especially if you want to calibrate something from the brain. You need some, P300. You need averaging, time-locked averaging to understand your evoked-related potentials, or other signatures that maybe are, single trial very fast, but need some transfer learning from other subjects with a similar anatomy and then similar responses. So it's a huge topic, and AI will help, I'm sure about that.
So yeah, to answer Richard's question, I love doing performance. I love working with performers. I think it's great, but deep down my soul, I'm an installation artist. I have a kind of sculptor sense. I mean, I'm also interested in music, so I make interactive systems that make sound and architectural scale stuff. And I would really love to start applying this to architectural environments that are interactive. Um, and that's extremely challenging. Trying to think about what that is and what would that mean. What would that mean if you could measure someone's biophysiology and have the space changing, in relation to that. And so those are some things I would like to explore. And we have explored them a little bit, and then in terms of how to disseminate this to others. So, well, very, very, that's happening now. So it happens in my lab with my students. Several of my students have this technology and they're exploring with it and making art with it. I've been working, we shared this technology with a fashion designer named Anouk Verprecht, who I don't know if you know who she is.
She works with GTech.
And yeah, and she's yeah, here we go, and she's been working with it, playing and making's the same, I guess. And she's about to release something. I think I'm not supposed to say too much because she wants to release it. So in the coming months, and that's also part of the reason we went to the workshop in Portugal. And then eventually, as this becomes street ready, we want to get it out there for the wider public. So.
Yeah, it's amazing. And I have a question along those lines from Richard's question. So if you were to devise a responsive system to be used as a musician during a concert, as a performer, but playing guitar, for example, or bass, would you envision a communication with the audience or a device that communicates with the audience to bring the performance to the next level of communication that is not only one way towards the audience as a performer with the music, but also collecting the impressions from the audience and having some sort of feedback as an artist to see, what's the response, the emotional response from the audience.
Yeah, that's super interesting. Well, with the music and like interactive systems that interact with music, there's a huge history with that. And there's a really famous book called Machine Musicianship by Robert Rowe, and there's work done by a composer named David Cope, and and this is like work done in the 80s and 90s, and a lot of that's based on like ANN, like neural nets and stuff like that, but it's also really interesting to think about like what would that loop be like, rather than an ANN, but some kind of emotive assessment machine, or maybe it uses an ANN, or so that's one level. But some of the work that we've been doing in this collaboration, like we did a study, a user study, and one of the things that we're interested in exploring is this idea of transference. So, or this is what Erica and Kate call it, and it's this idea of how so they believe that through their methods, the somatic methods, and presenting this physiology in this like, and in this kind of embodied way, that they that should help them transfer the experience of the character to the audience, more effectively than other methods. So we decided, well, let's measure that. And so what we did was we got people who are trained in our system, and had some of them perform what they call loaded, so meaning they're warmed up, and because it takes a while to get into the somatic state, and some who weren't. And then we had audience hooked up to ECG and EDA watching, and we watched their arousal and their emotive responses to the performance. And so now we have a bunch of this data, and we're looking to measure that. But so that's something we're really interested in. It's like there's really kind of several levels to this work. So one is the individual feedback, which we've been talking about a lot. There's the feedback between two people, which also relates to that, like heart and hand. And then there's the group experience, which relates to like entrainment, but also like performers with each other in large ensembles, but also performer and audience. And then when you start doing things like in installation performances where you blur the line between performer and audience, where there's no stage, there's proscenium, you're moving through, that becomes something else. So those are really kind of the levels of the work. And then having this cybernetic system, behind the scenes, trying to adapt in response to everything that's happening.
I love this event today because in the spirit of the showcase, applications that come to mind here, which is the season's theme, are infinite, right? You name it, the sky is the limit. You spoke about so many different levels at the level of performing arts, in this case, music, and acting, that you can only think of, 1,000 applications out of this. And then one that comes to mind, for example, is, like you mentioned, the communication among components of an ensemble, playing jazz, for example, or playing, any sort of music. Do they entrain to the music? Do they entrain to something else? What is that they entrain to, right? Is that tangible, what they entrain to, or is the music driving their emotions, or the other way around? And how do they communicate? How do you select bandmates? If they come to a rehearsal, are the ones that entrain better with you? Is normally you can tell because there is chemistry, but this episode is fantastic because now we have an impression on how to measure that.
Mm-hmm.
I do have another question, by the way, from Aaron Kemp. He's asking potential therapeutic applications to investigate emergent group dynamics among a group of patients with Parkinson's disease while learning Tai Chi routines. Is that, for example, something that could be used? I think, if I interpret the question.
Well, I hesitate to talk about anything clinical. So it's a little bit, I know we're kind of like we're like really in this world of psychophysiology and, all this, but I'm just like so unqualified to speculate about anything clinical, for this work.
We need FDA clearance.
Yeah, exactly. I better not anyway, right? So, yeah.
That's why we call it wellness and stuff like that. It's always on the safe side.
Yeah,
I agree
we're
with you.
making art. It's it's a tricky. The whole thing's tricky. So, I mean, we have to be very careful about ethics. I mean, technically, like you're saying, this is a recording device, but actually, we don't store any data. I mean, it's stored technically in a buffer, right, before it's sent, but we don't really record data very much.
Doesn't have a SD card or memory device. Interesting.
No.
We went into this.
I mean, you can record it. You can just make it. You can record it if you want to. I mean, there's no way to prevent that. But as simple as any audio recording. But it's we're really looking at real time. What we can do real time.
It's not like the Fitbit that everything goes to the cloud. Sorry to go back to the same example as before, but your heartbeats are functionally interpreted during the performance. It's not something that you store to, carve out statistics of the individual, I guess.
Yeah, well, if we do that, we're going to do that in a separate study, and then we have to go through ethics review and stuff like that. So
it's so good that you mentioned that.
Mm-hmm.
We do have actually an upcoming theme of one of the next seasons that will deal with data, data broadcast storage, privacy, access, and how to manage data from human recordings, in specific neuroscience EEG recordings or any sort of neuroimaging recordings, but also telemetry such as personalized telemetry such as heartbeat or heart rate variability, which depend on the individual and their sensitive data, right? So now you were mentioning the Fitbit previously, which brings us back to the theme of data sharing and how recognizable the data from a single person is if you share it. And it opens up, a number of questions that we addressed in the previous episodes, as how safe and secure it is to record data from the individual if then it's stored, and does it require the consent of the individual, and how to go about that, and who has ownership, who has the right to sell and market this data. This is a very sensitive topic, not only for diseases or for medical ailments, but also in general for that data acquisition from the human body. I think if it's functional to a performance, it's great. We can think of many applications, but it becomes easily, very quickly sensitive data.
Yeah. Well, I guess my take on it is I think historically technology is good and evil, and I don't know, we can get into the kind of like, there's a McLuhan argument, about, I don't know, there's this argument about, like what good is a gun? I mean, it's a little less controversial conversation in Canada maybe than United States or something, but, it's like, what is the purpose of the gun? And the gun is designed to kill, and then say, well, if you're killing the right things, I guess that's okay. And then, but besides, let's say certain weapons of war and things like that, like the computer or the phone, they're both good and evil. They're, and I think the same with this kind of thing, like you're saying, we had many examples or describing how these tools, like through consciousness hacking or other kinds of wellness, that we're able to maybe improve our lives, and but it also could be a ways of dividing us, or and or categorizing us, or things like that, and so I think that's I don't know, there's a couple ways to go about it, and I think both are right. You can protest and argue and fight, and fight for the privacy, and we should definitely be doing that. But I also think we need to be showing the way to a better approach to using these technologies, and by trying to think about how to make a better world through exploring what can be meaningful and what's great about it.
Well, Mark David, as great contribution from your side. I'm sure there is plenty of people among the audience participants today that would like to reach out to you, and they express already explicitly their interest, as it never happened before, honestly, in this episode. So I'm really happy about this success of your presentation. And I would like to close with a remark. We don't have so many occasions in NeuroTechX Showcase to have artists. We are a community of neuroscientists and technologists, and I would like to thank you for opening up our vistas towards the workings, behind the scenes workings of artists, and how much work, and giving us the dimension of how much work they put into and how systematic they are in their work. And it's it's a science to be an artist, and it's hard work. So I would like to thank you for this contribution, and I know that you can maybe briefly mention an inspiring manifesto of what it means to be an artist, and to give a final touch of this word, if you allow.
Oh, it's a wonderful invitation. It's like you read my mind. So I've been reading, or I was reading this artist named Agnes Dennis, and she's an artist. She's now in her late 80s or something, but from the 70s as an environmental artist. Very interested in art, science, and technology, and really a woman ahead of her time. And she wrote a manifesto in 1970, and so I think that's the manifesto I'll read. It's not that long, so I just happen to have it here. It's working with the paradox, defining the elusive, visualizing the invisible, communicating the incommunicable, not accepting the limits society has accepted, seeing in new ways, living for a fraction of a second and penetrating light years, using intellect and instinct to achieve intuition, achieving total self-consciousness and self-awareness, being creatively obsessive, questioning, reasoning, analyzing, dissecting, and re-examining, understanding the finitude of human existence and still striving to create beauty and provocative reasoning, finding new concepts, recognizing new patterns, desiring to know the importance or insignificance of existence, seeing reality and still being able to dream, persisting in the eternal search.
This is a great end to our episode. Thanks, Mark David. And this was truly inspiring. I'm not the only one to say that. For our audience, I would like to remind everyone that we have an episode number 4 in 2 weeks. Eden and Ore will present again in applications, hardware and software. And with this, I thank everyone, and I wish you a very good night.
Thank you, everyone.